All right, grade 8s. We're starting chapter 9, linear relations. 9.1 is analyzing graphs of linear relations. 9.2 is patterns in a table of values. Then we'll have a quiz. Then 9.3 is linear relationships. To wrap up the chapter, there will be some review and then, of course, an exam. So, 9.1, analyzing graphs of linear relations. What is a linear relation? Well, we've got a definition here to start us off. It is a pattern made by a set of points that lie in a straight line. So on this graph, we've got a bunch of points, and if you were to connect them, it would create a straight line. So linear itself actually means straight line. And the table of values shows two sets of related numbers. So for this graph, a table of values would include your x and your y coordinates for these different points. Working example number 1, make a table of values from a graph. So we've been given a graph, and the graph shows that the total cost depends on the number of baseballs you buy. So the number of baseballs you buy is across the x-axis, and the total cost is on your y-axis. So the total cost and the number of baseballs are actually related to each other. So on the x-axis, we're using the variable b to show the number of baseballs, and on the y-axis, we're using a capital C to represent the cost. Describe the pattern that you see on the graph. Well, the graph shows data on the cost of baseballs. One ball, if you follow it, looks like it costs $3. 2 balls is $6. And then 3 balls is $9. And then it goes on up from there. So the total cost increases by $3 each time you buy a baseball. So 1 is 3, 2 is 6, 3 is 9. To move from one point to the next horizontally, so to go from one grid line to the next, you're moving 1 unit. And to do that, you're moving up 3 units each time as well. So that's a relationship. If you move to the right 1, you move up 3. The points lie in a straight line. So this graph shows a linear relation. Part B, make a table of values from the graph. So you read each point as an ordered pair to make a table of values, and we can complete each table. So in the horizontal table of values, the top row indicates the x coordinates, and the bottom row is the y coordinates. So the x coordinates in this case was the number of baseballs, or B, and the y coordinate was our total cost, or C. We saw that 1 baseball costs $3, 2 was 6, 3 we said was 9. And if we go back to the original chart here, we can see that 4 baseballs costs $12, which is what we should expect as this goes up by 3 each time. And if you're using a vertical table instead of a horizontal one, the first column is your x coordinate, and the second column is your y coordinate. So again, 3, 6, 9, 12, we're skip counting by 3s. Write an expression that represents the cost of buying baseballs, B. Let B describe the number of baseballs, and the cost, or the expression 3B describes the cost of buying baseballs. So if this is B, C is 3 times that. If we 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. You can see this relationship here. So if that's the case, then C is equal to 3 times B. If this relationship in the graph continues, how much will it cost to buy 14 baseballs? Well, you don't have to draw out all the numbers. Now that we've seen this pattern, we've created this equation, and we can actually calculate it out. Use the expression 3b to find the cost of 14 baseballs. So, if 14 is the number of baseballs, that's the letter B in our equation. So 3 times 14 is equal to the cost of 14 baseballs. And 3 times 14 is 42. So the cost of 14 baseballs is, in fact, $42. So now we've taken a graph, we've interpreted the data on it, and we've been able to forecast something that's not actually included in the graph. So now it's your turn to do a show you know. Please go ahead and do that.